Good evening and welcome to Tinkering with Edkelar. It is time for a bit more tube-based equipment again. What I have here is a piece of audio gear that was made in the tail end of the tube era. It is a model 3D-1 by a company called Sentinel, a wow and flutter meter. Now, I'm not an expert on this subject, but allow me to briefly summarize what wow and flutter is. Analog audio recording devices usually have their playback speed derived from a simple electromechanical construction. Not much of regulation going on, but only when the recorded signal is played back at exactly the same speed as it was recorded will it sound perfect. There are two possible variations in the reproduction process. One, the absolute speed isn't quite matching, and two, the speed fluctuates and isn't quite constant. Wow and flutter are the latter category. There are different opinions on what amount of speed variation is audible, and people can get quite passionate about it. We'll look into the wow and flutter in a bit more detail a bit later, because now I'm itching to see what's on the inside. The unit was sold on eBay as is, and it was cheap and looked the part. The case is a bit banged up, a bit rusty and scratched. Let's get into the guts of it. The construction is typical for tube stuff. The front panel and inner chassis slides out of the case in one piece. Now the inside looks rather clean. Let's check the base. Oh, that's a new one. It uses a PCB with some point-to-point wiring. Interesting combo. I haven't seen that before. The components all look like factory new. The upper side also looks pretty good. Only two things are off. The DC filter cap is dented and there is something oozing out from underneath that one metal can. I put the project on hold a bit, and when I carried it from my car to my storage, what was left of the handle broke and I dropped it to the floor. Humph! At least the meter seems to be in working order. The needle moves and I can zero it out mechanically. Also, the knobs are a bit odd. One chicken head knob and three others, of varying styles, with one axle even bent. And not by my drop, I must add. Oh, there's only one rubber foot left. Needs new ones. With the tubes numbered and the trimmers labeled, this unit seems to have been opened before. Anyhow, let's remove the tubes. The power cord has a US plug. I'll replace it with a European one. But the strain relief was anything but easily relieved. Now to take care of the control bits. There are 7 banana sockets around the unit, 1 on the rear and 6 on the front panel. The power indicator light was also not held in properly. The lens part was stuck to the nut that was supposed to hold in the socket. The meter movement is next. And the banana sockets seem to be very much different styles all over, just like the buttons. Interesting though, the chicken head knob didn't even have a set screw in it. It held on by sheer grime. I want to clean the front panel, so all the components need to come off from there. The Discriminator centering control is a trim capacitor. Interesting. And ta-da! The front panel comes off. Let's see if it cleans up. Removing the PCB to gain access to the screws that hold the transformer and the two black boxes in. I'm trying to avoid desoldering the tube sockets, which are riveted, and the wiring is very short. So in order to flip away the PCB, I need to remove all the stuff from the rear panel too. Removing what was left of the handle. That leaves a large gap. The replacement handle I found only has screws, not clamps. I need to make an adapter for that. There is this neat plaque with a summary on how to use the unit. I'm drilling out the rivets so I can paint the case and keep that intact. repainting the case. I found a manual online, not for free mind you, but it does seem to be a reasonably priced reproduction. At least it also has a circuit diagram. The two black boxes seem to be transformers of sorts. Even the schematics just lists the model number. And they are potted. The potting compound of one is slightly leaking out. That's why there is goo under its case. Now the main DC filter cap is a typical 2-in-1 model. It has a dent, and I'm going to put in new caps into that can. And again, I have to remember to tell stagehands, never assume that the case is sturdy enough. Always use a live center. Darn, that took some damage. At least I got out the goo, whacking the case into the approximate shape again. And the two new capacitors are just so a bit too tall. The original cover doesn't fit anymore, and thus I cannot close it properly. But a dab of epoxy should hold the cover in place. With all the wires having heat shrink applied to them, there is no chance of them shorting it out. I also replaced the one other electrolytic. It is across the meter movement. Seems to me that this is dampening the result so that the needle doesn't bounce too quickly. The shaft for the trim capacitor is actually just a bolt. It comes out and can be straightened. What's weird about the trimmer control is the totally marred up shaft. It seems that somebody was over tightening it. Strange. The mains switch and input attenuator pot is next, giving everything a good clean and putting it back together. The actual switch is riveted, so I cannot dismantle it, but it shows up as 0.2 ohms, and that's good enough, I'd say. The wafer switches are odd. Seems that they are the same basic model, but one is using screws, the other is riveted. Time for the drill again. With the switch mechanism covered in plastic, I couldn't scrub the contacts, but at least I could flush them out with contact cleaner. Taking apart the trim pots for a good cleaning too. These calibrate the meter deflection for the different wow and flutter modes. also opened up the meter, both to check if there's any dirt in it and to clean the glass properly. Closing the meter was a chore. The scale plate is held in place by the case clamping down on it. No screws. And it does bind up a bit when closing the case, so there is a risk of it popping up and damaging the needle in the process. Took forever to finagle that together again. The standoffs for the PCB were loose. I put in a bit of thread locker to try to keep them at bay. I opened up the transformer case and gave it a good clean. The schematic tells me the transformer can be rewired for 220 volts. That's nice. No need for rewinding or replacing it. Yes, I know, the cap was mounted from underneath the chassis. I fixed that off camera after a few strong words. Yes, the connections to the new caps are a bit wobbly, but I checked. To short out, they would need some serious bending. Not possible by regular use or just bumping. The replacement electrolytic goes in next. Note that I accidentally connected the yellow wire here too. But that is actually for the rear banana plug. Whoops, almost forgot about that one. I can't help myself, I have to repeat how weird this device is to me. Tubes on one side and plenty of glass diodes on the other. A living anachronism. Or at least I hope it will live. And mounting the front panel again, starting with the meter movement for better access. I also got a set of new banana plugs, but these are way too cheap. The rear thread for holding them in works just fine, but the front one for clamping down on the wires, sheesh, that's wobbling so much it skips a thread every now and then. I might have to replace those at a later time. Right now I don't have the budget for expensive ones in a matched set. And to top it off, new knobs. I got replica chicken head ones for the main controls and a round one for the trim cap. That makes sense, since that one is not really aligned with anything. Doing a quick check on the tubes. All in working order. I couldn't check the regulator tube, but these are usually fine. Now to the power on, checking the transformer first, making sure that we have the right AC voltages on the rectifier. Now I'm adding the indicator lamp, but it wouldn't turn on. Odd, all the wires seem to be connected. It took a bit of detective work to find out what was wrong. You see, the meter has a regulator tube on the main B+ rail over here. This works a bit like a Zener diode. If enough current flows through it, it will hold the voltage on a constant level. This means that you can put the rest of the circuit in parallel and have a nice regulated supply. The difference between the input and output voltage will be burned off by the input resistor. That's good, but what happens if you pull that tube to replace it? Without the tube installed, there is nothing to pull down the voltage rail, and the almost full DC output from the transformer will hit the circuit. This is why these tubes come with breaker connectors, or at least that's what I call them. That's a bridge wire inside the tube that shorts two pins on the socket. Usually these are connected to the high voltage output side of the tube. Pull it out and the downstream circuitry will be left without B+. In this case, however, the breaker line is connected to the ground of the circuit. That means without the regulator tube, the full B+ will still go everywhere, but nothing is grounded towards the rectifier, including all the heaters and the control lamp. So adding the rectifier and the regulator tube, and lights on! Next, checking B+, both before and after the regulation tube. Time to populate the tubes again. Good thing I made pictures, cause the handwritten numbers next to the sockets don't fit any of the schematic numbers. Meh. Now, before I do measurements, let's check out the reference oscillator. The meter provides a 3000 Hz sine output, so you can record the reference signal yourself and then see how the playback looks. Mind you, that doesn't check absolute speed, but at least you can get an accumulated error between recording and playback speed fluctuations. Sweet! Nice sine wave and only off by a few hertz too. The trim capacitor in the rear is the adjustment point here. Speaking of which, how is WoW and Flutter even measured? I never really thought about it until now. If you need a bit more in-depth description, there are plenty of videos on YouTube about the subject matter, but I'm still going to summarize my findings here. First off, to measure WoW and Flutter, you need a recorded reference signal. This is most commonly around 3000 Hz. My unit here and most of the test audio I have is exactly 3000 Hz, but there is also a 3150 Hz definition around. Now, I have heard people referring to the absolute speed mismatches, like running fast or slow, as WoW or Flutter, but that is not true. The absolute speed can be calibrated with a frequency counter just fine. If the output of the device is more or less than 3000 Hz, it runs slow or fast. End of story. Wow and flutter both refers to the irregularity of the speed, usually caused by mechanical issues like some gears or pulleys dragging, or the supply voltage instabilities. Worn out belts might also cause erratic wobble on the mechanism, so wow and flutter both refers to fluctuation in the output, which means that the output signal isn't exactly 3000 Hz, but rather a bit more and then a bit less from 1 second to the next. Or, as we've shown here a bit exaggerated, the sine wave will bunch up and stretch a bit, which is a frequency modulation. Aha! So that's how you measure it and turn it into a number. The speed differences are visible as a signal that is frequency modulated on top of the 3000 Hz carrier wave. In that way, you can extract the frequency mismatch as a new frequency, which ideally should be DC, that is 0 Hz. The more instability, the higher this error frequency gets. Pretty simple. And here is where the distinction between wow and flutter comes in. Wow is low frequency wobble, up to about 6 Hz on this machine, and flutter is 6 Hz and up, on this machine up to 250 Hz. The different readings are made possible by filtering the high or low portion of the display, or, more common these days, you can show both ranges as combined wow and flutter value. What I don't know is how these are weighted. I have seen different specifications for how annoying different error frequencies are, and so there is a weighing involved in the final value. Not sure which curve this unit follows, or if it is weighted at all. At any rate, it will be useful to compare different devices. But overall, I learned something. Now, back to the meter. Now to feed a signal into the meter and see what it has to say. First off, this circuitry filters out anything too far away from the 3000 Hz. So it makes sense to start with a clean 3000 Hz sine wave of about 1 volt input. The first step is to calibrate the input level. The meter selection goes to level and then adjust the input attenuator for a mid-meter reading. That works. Next, you want to fine-tune the discriminator. That is the carrier frequency for the FM demodulator. To do that, you put the meter into disc mode and then tune for a 0 reading. Not quite. That explains the bad shape of the trimmer knob. Somebody used force to try to get it in tune. The problem here is that the trimmer only has about 1 nanofarad of range, and the fixed capacitor that it is supposed to tune is 10 nanofarad nominal. So they expect the total capacity to be around 11 nanofarad, but the fixed cap seems to have drifted a bit. It measures only about 8 nanofarad, so far too little to get anywhere near the nominal value. I put a small new cap in parallel to compensate. With that additional one, the tuning now works just fine. I can lower and raise the reading to about equal amounts. Now here's where the biggest problem starts. I need a few reference signals to check the readings, but I don't have any. At any rate, the good sine input from the frequency generator yields a plausible 0 reading on both ranges and all filter settings. I found a plugin for Audacity that creates a wow and flutter reference signal. Not quite the value range I need, but at least I can check if the reading makes sense. The 3 trimmers were labeled total, 0.5 and 2, but the schematic tells me one is the total for all base value and the other 2 trim the filtered wow and flutter ranges. They have nothing to do with the meter range, 0.5 or 2%, that one is hardwired based on a resistor divider. So who knows how far off the unit was before I cleaned the pots. I took the adapter sleeve from the original broken knob and put it into the new one, so it fits on the tiny axle. For the case, I made a pair of aluminium blocks. They have a hole in the center and a slight step around the section where there is a hole in the case. That way, the screw can remain centered and will not slip out when carrying the device. For the quick reference plaque, I found some screws that fit nicely. And new rubber feet. 4 of them even. And mounting the chassis to the case again. Now I'm still looking for a set of reference signals in digital uncompressed form so I can compare the absolute values. If you have some, please let me know in the comments. And that's it. Any recording device I restore shall go through the wow and flutter test from now on. Yay! Of course, there's also a digital version available that can work with sound cards, but where's the fun in that? Anyhow, I hope you enjoyed this restoration. See you next time! When you use an audio recording device, the audio recording is usually tied to the speed of which the recording is moved. Too much recordings in one sentence, darn it. It is time again for a bit of tube-based equipment. What I have here is a piece of audio equipment. Too much equipment this time. With all the wires having shrimp, of course. Shellfish, yes, why not?